1. Task Introduction. This task focuses on clarifying the adjustment process of the servo drive unit, understanding the parameters that require adjustment, and being able to correctly modify these parameters. In cases of performance deviation, you should be capable of improving the operational performance of the servo drive unit through appropriate parameter tuning. 2. Learning objectives. Knowledge objectives. Understand the adjustment process of the servo drive unit. Clearly grasp the content and meaning of each step in the parameter tuning process. Learn how to adjust the rigidity of the servo system. Skill objectives. Clearly understand and follow the servo drive unit adjustment procedure. Be able to accurately adjust the servo drive unit based on operational requirements. Be capable of correctly tuning the rigidity of the servo drive unit. Caliber objectives. Develop a spirit of teamwork and collaboration. Strictly follow standards and norms, and develop a rigorous and scientific work attitude. Cultivate the habit of summarizing the training process and outcomes to gain experience for future training. 3. Guiding questions. 1. What is the purpose of adjusting the parameters of the servo drive unit? By adjusting the parameters of the servo drive unit, the data of the servo drive unit is made to match the motor load data, ensuring that the motor's performance meets the requirements of machine tool operation. 2. What are the steps involved in the easy parameter tuning process? The easy parameter tuning process for the servo drive unit. Step 1. Set the motor model. Step 2. Configure the type of control instruction. Step 3. Set the numerator and denominator of the electronic gear ratio. Step 4. Configure the analog speed scaling factor. Step 5. Set the alarm output polarity, limit switches, application scenario, and load type. Step 6. Save the parameters. 4. Knowledge description. 1. Description of the servo drive unit operation panel. As shown in the diagram, the operation panel of the servo drive unit mainly consists of a 7-segment display indicator, decimal point indicators, and function keys. 1. 7-segment display indicator. As illustrated, the 7-segment display indicator primarily indicates the function group, parameter number, and the specific set value of the selected parameter. When setting parameters, first, identify the function group that needs to be configured. After entering the function group, the current parameter address will be displayed, followed by the current setting value. Users can choose to skip adjustment or modify the value as needed. 2. Decimal point indicators. Dot 1. No function assigned. Dot 2. Indicates the sign of the data. When lit, it represents a negative value. When off, it indicates a positive value. Dot 3. When setting parameters, it distinguishes between the current object group and the address data within that group. When displaying internal 32-bit data in real time, it indicates the high 16 bits of the 32-bit data. When displaying error history, it displays the oldest error. Dot 4. In real-time display and data adjustment mode, it indicates the data display format. When lit, it means hexadecimal. When off, it means decimal. When displaying error history, it displays the most recent error. Dot 5. When lit, it indicates that the data modification was successfully confirmed. When off, it indicates that the current display shows internal system data. When blinking, it means the power section of the drive is currently active. 3. Function keys. Mode. Used as switch function menus. During parameter adjustment, short press to shift positions, and long press to return to the previous menu level. Set. Used to enter menus and view parameter setting values. When displaying internal 32-bit data, long press to switch between the high and low 16 bits. Up arrow, short press to slowly increase the set value. Long press to quickly increase the set value. Use to switch between data items. Down arrow. Short press to slowly decrease the set value. Long press to quickly decrease the set value. Use to switch between data items. 2. Servo drive tuning. 1. Parameter setting procedure. After powering on the system, follow these steps. Step 1. Set the CPU version number. Step 2. Set the drive ID number. Step 3. Perform easy parameter setup. Step 4. Perform tune parameter setup. Step 5 and beyond. Sequentially configure parameters F001 through F007. 2. Easy parameter setup. Easy use is designed to enable quick configuration of control loop parameters, streamlining the servo tuning process. The adjusted performance is well suited for most application scenarios. A dedicated parameter section is provided to facilitate user configuration of frequently used and critical parameters. 1. EA01 Set motor model. For factor new drives, the motor model is set to 00 and the digital display shows 3030. If the correct motor is connected, the drive automatically identifies and stores the motor model. The digital display will not flash FFFF if the motor is correctly recognized. For previously used drives, the drive checks whether the connected motor matches the previously stored model. If different, the digital display flashes FFFF. In this case, the user must manually confirm the motor model and parameter EA01. 2. EA02 Set control command type. Change the command type by adjusting the rightmost digit on the 7-segment display. 0. CW clockwise or counterclockwise pulse mode. 1 PD pulse plus direction mode. 2. AB phase pulse control mode. 6. Analog speed mode via channel 1. 7. Analog speed mode via channel 2. 8. Host communication control mode. 3. EA03 and EA04. Set electronic gear ratio, numerator and denominator. These parameters are valid when EA02 is set to values between 0 and 2. By default, values are displayed in decimal. Values exceeding 10,000 are displayed in hexadecimal. 4. EA05 Analog speed factor. These parameters are valid when EA02 is set to values between 6 and 7. It defines the relationship between the analog input voltage and motor speed in units of revolutions per minute per volt. The parameter must meet the following condition. Negative 32,768 is less than or equal to n times ENC divided by 750, which is less than 32,767. N, the value to be set, ENC. Encoder resolution, refer to Object Dictionary OD 0x641003. 5. EA06. Alarm output polarity, limit switch, application scenario, and load type. From right to left, the digits on the 7-segment display represent. Load type affects control loop parameters. 0. Not selected. 1. Belt driven. 2. Ball screw. Application scenario affects control loop parameters. 0. Point-to-point mode. 1. CNC mode. 2. Master-slave mode. Limit switch. 0. Default limit switch settings, DIN5 and DIN6. 1. Disable all limit switches. Out to alarm output polarity. 0. Normally closed. 1. Normally open. 6. EA00. Save parameters. Write 1. Save all parameters. Write 2. Save all parameters and restart the drive, required after changing the motor model. Write 3. Restart the drive only. Write 10. Initialize parameters. Once parameters are saved, The drive automatically configures control loop parameters based on the specified load type and application scenario. 3. Tune parameter configuration instructions. After completing the easy setup process, the drive will automatically select appropriate rigidity and inertia ratio default values based on the load type and application type specified in parameter EA06. If the inertia ratio of the mechanical system is already known, it can be directly entered using TN02. See the table for reference. If unknown, the user needs to adjust parameters and observe the motor behavior to determine suitable values. 1. TN01. Rigidity level. Range 0 to 31. It determines the bandwidth of the speed loop and position loop. The higher the value, the higher the rigidity. Note, start with a small value and increase gradually. Setting a value too high may cause a significant increase in system gain, leading to strong mechanical impacts. Recommended values: belt-driven systems 10, ball screw systems 13. 2. TN02. Inertia ratio. It represents the ratio of load inertia to motor inertia multiplied by 0.1. For example, if the 7-segment display shows 0050, it means the inertia ratio is 5. The drive calculates the load coefficient, K-load, based on the inertia ratio, which affects the velocity proportional gain, KVP. The formula is KVP equals VC loop BW times K load divided by 4096. VC loop BW represents the speed loop bandwidth. Recommended values: belt-driven systems 50, ball screw systems 30. 3. TN03. Inertia measurement. Write 1 to enable the motor and start measuring the inertia ratio. During measurement, the motor will make small oscillatory movements. Once completed, the rigidity level is set automatically between 4 to 13 based on the measured result, and TN03 will display 1. 4. TN04. Tuning distance. It specifies the axis movement distance during tuning, multiplied by 0.01. For example, if the 7-segment display shows 0022, it represents 0.22 revolutions. The maximum allowed value is 0.4 revolutions. Default value is 22 and typically does not require modification. 5. TN00. Save parameters. Write 1. Save all parameters. Write 2. Save all parameters and restart the drive, required after changing the motor model. Write 3. Restart the drive only. Write 10. Initialize parameters. 4. Other commonly used adjustment parameters. 1. Speed loop interval gain. Parameter D2.02 in group F002. This parameter adjusts the speed loop's ability to follow commands. Begin with a higher value. If oscillation occurs, gradually reduce it until the motor runs smoothly. Setting range 0 to 65,535. 2. Position loop proportional gain. Parameter D2.07 in group F002. This parameter adjusts the position loop proportional gain, KP, unit, 0.01 Hz. A larger value improves the motor's following capability. Typically, this should be set relatively high. Note, ensure the same value is applied across all axes to prevent machining inaccuracies caused by inconsistent settings. 3. Maximum speed limit, revolutions per minute. Parameter D2.24 in group F002. This parameter sets the maximum rotational speed of the motor. Setting range 0 to 15,000. 4. Maximum following error 16. Parameter D2.25 in group F002. This parameter sets the maximum allowable deviation between motor feedback and system command. The formula is maximum following error equals 100 times maximum following error 16. 5. Digital input terminal function definitions. Digital inputs DIN1 to DIN7 are configured via parameters D3.01 to D3.07 in group F003. Common function codes include 0001, drive enable, 0002, drive alarm reset, 0004, drive operation mode control, 0010, positive limit switch, 0020, negative limit switch, 0040, home signal, 0080, reverse velocity command, 1000, emergency stop, 8100, motor fault. 6. Common motor-related parameters in group F004. D4.02, feedback type, encoder type. Bit 0, UVW signal check. Bit 1, Nikon multi-turn absolute encoder. Bit 2, Nikon single-turn absolute encoder. Bit 4, ABEZ signal check. Bit 5, reduced wire encoder. D4.03, motor pole pair count, set according to the actual specifications of the motor. D4.09, maximum motor current, set according to the actual specifications of the motor. D4.17, motor rotation direction. If the motor rotation is opposite to the required direction, adjust this parameter. 0, forward rotation. 1, reverse rotation. 5. Task implementation. 1. Become familiar with the meaning of the numeric and dot indicators on the servo drive. 2. Practice using the mode key, set key, up arrow, and down arrow to modify tuning parameters. 3. Perform easy parameter setup. 1. EA01. Set motor model. Set the motor model to 00 to initialize the system as factory default. 2. EA02. Set control command type. Set it to 1 for pulse plus direction mode, PD mode. 3. EA03 and EA04. Set electronic gear ratio, numerator and denominator based on a lead screw pitch of 5 mm. Set the gear ratio to 1 to 200. 4. EA05. Set analog speed factor. Based on the formula. Negative 32,768 is less than or equal to n times ENC divided by 750, which is less than 32,767 and encoder resolution. Determine and set the value of n, analog speed factor. Adjust the value of n appropriately as needed. 5. EA06. Configure alarm output polarity, limit switch, application scenario, and load type. Alarm output polarity, normally closed in C. Limit switch, set to 0, default current configuration. Application scenario, set to 1 for CNC mode. Load type, set to 2 for ball screw systems. 6. EA00, save parameter settings. Set it to 1 to save all parameters. 4. Tune parameter configuration. 1. TN01, rigidity level. Gradually increase the rigidity level step by step, aiming for smooth operation and strong following performance. For ball screw systems, a typical setting is around 13. 2. TN02, inertia ratio. Set the value to approximately 30. 3. Set TN03 to 1 to initiate inertia ratio measurement. Observe the motor operation. After the measurement is complete, check the updated value of TN02. 4. Set TN04 to 22 allowing the motor to rotate 0.22 turns for parameter tuning. 5. Set PN00 to 1 to save all data. 5. Commonly used parameter configuration. 1. Speed loop integral gain. Initially set a relatively high value, such as 50,000. Run the motor and observe its behavior. If vibration occurs, gradually reduce the value until smooth operation is achieved. 2. Position loop proportional gain. Similarly, begin with a relatively high value to enhance following performance. Operate the machine tool, and if vibration occurs, decrease the value gradually until the system operates smoothly. 3. Maximum speed limit, revolutions per minute. Based on the required axis operating speed and the lead screw pitch, calculate the necessary maximum speed. Increase the calculated value by 20% to determine the maximum speed limit. 4. Maximum following error 16. According to the formula, maximum following error equals 100 times maximum following error 16. For a desired maximum following error of 10,000, calculate the value of the maximum following error 16 accordingly. 5. Define digital input terminal functions. Based on the control circuit design and predefined terminal functions, configure the functions of digital input terminals DIN 1 to DIN 7 by inputting the corresponding values for each. 6. Configure common motor-related parameters in group F004. Set the encoder feedback type to Nikon multi-turn absolute encoder. Set the number of motor pole pairs according to the actual specifications of the motor. For CNC machine tools on the production line, this is typically set to 2. Configure the motor's maximum current based on its actual specifications. Adjust parameter D4.17 to correct the motor's rotation direction so that the work table movement aligns with the defined positive or negative direction of the axis. 6. Operate the machine tool to validate parameter settings. If issues such as vibration or stick slip occur, make corresponding adjustments until the machine operates stably with strong following performance.